Hello. As I said, we will be talking about here mainly the supervised learning, and I will try to show you the real-time program that has been written. But just bear with me for a couple of more minutes to help you understand the concept, because concept is main, and we'll replicate the same into the code. So in supervised learning, what we used to do, we just try to collect the training data as much as possible. Then we train the classifier that it can classify the data, and then make our predictions. I can give you a small example. Let's say we want to train our data in such a way whether we want to classify whether it's a cricket ball or a tennis ball. Cricket ball, I'm talking about the leather ball whose edges definitely will not be smooth, a 4-piece leather ball, and you have tennis ball, plain smooth. So the you can see here, so the type of ball or what is the classifier, whether it can classify whether it's a leather ball or whether it's a tennis ball, and it will give the predicted output. So if you see here very carefully, these are the different features that could be associated with two. If I have to make the assumption between the cricket and the tennis ball, so if you see, if I have to achieve it through writing all these rules manually by ourselves, so you can see how much cumbersome it will be. You may first think to figure it out on the basis of the color. If it is brown or red, it should be cricket ball. If it is green, let it be tennis ball. But what will be the case when it comes uh, for the black and white images? And believe me, in the real life you have uh, tons and tons of such different images and data, and real life challenges are completely different. So it is not scalable. You cannot write each and every rule. That is the reason machine learning comes into picture, where it will get the data, predict the data based on the training data. So for this, what you need to do from coding perspective, I would say, so you should first download the Anaconda is a framework. This is the most popular Python data science platform, where you can write the sophisticated code, I would say. And you can see already they have these many customers that are already using Anaconda, and more than that, to be honest, a lot of startup companies are already using it. And you can use the SciKit. It is kind of an open source library where all these Numpy, SciPy, Python is already readily available within it. Within Anaconda, Python is already, I would say, gets installed along with it, so you need not to worry about it. It's a complete package. And SciKit is, let's say you want to use some for mathematical uh, complex, I would say, scientific calculations. We have Numpy arrays and even the Numpy matrix. So Numpy is the library for it, so you can use it. I will not be here demonstrating how to install it, because there are a lot of videos already available and you can get a good help over these websites. So I will quickly show you how the Anaconda navigator looks like. So it has a home, environment, learning specifically. You can go and learn. There are a lot of tutorials available. You can see a lot of open source things are there where people have contributed a lot, and I will not touch upon each and every part, but you can see some of the things that I would like to bring or highlight for you. This is the matplot lib documentation. This is mainly used for your analytics and mainly used for plotting the charts. For that we use this library. Similarly, you have Python tutorials, you can go through it. um, Similarly, you have the R and Python, Anaconda, all these documentations are here. Now I will go to the environments. So here, first thing what you can do is, by default you will get the base root, uh, where you can start using it. But let's say you want to create your own environment, test environment. The way I have created the test environment, you can create it, or you can clone any environment, you can import and you can remove also. The moment your environment is ready, you created it, you can import any library. That's what I was saying. SciKit or Numpy, all those things can be uh, installed into it by directly going to the command line and saying import, and it will be done. So I will go to, you can see I'm using Python 3.7 version. I have opened the spider from home. You can see I have already installed it. You can download the Jupyter. Jupyter is one of the famous for using or writing the data in or writing the code in Python. Similarly is the Spider. It is a scientific Python development environment that I have already installed and I have launched it after clicking here. So you can see I have launched it. So let us go and understand each line by line this code. So you can see I have imported the sklearn, then I have imported the Numpy for mathematical calculations if needed. As of now I'm not using, I can skip it, but still I'm just showing you how it can be done. And I have used some decision trees from sklearn that is readily available. So now we talked about features. I will quickly again show you. These were the features of the product. Based on that, we will label the outcome. So let's say you already have you can see here same thing I have tried to. If it's a 300 and not smooth, it should be cricket ball. If it is 150 gram and smooth, it will be a tennis ball. Similarly 320, it will be cricket ball, and if it is 130, again it will be tennis ball. So let me try to remove this not smooth with 0, with 1, and if it is smooth it should be 0. Same way, if it is not smooth, let's mark it 1, and if it is smooth, let's say it's 0. Similarly, if it's a cricket ball, let's say it's 1, and if it's a tennis ball, we will classify it as 0. Same way, if it is cricket ball, let it be 1, and if it is tennis ball, let it be 0. So now what we are doing here is, if you see, we are training the classifier, and we are not going to use any decision tree classifier as of now. Decision tree classifiers you can study further. This is something, it will make the decisions on based on a tree. Example, first it will check what is the weight, whether it's a 300 or 150. Okay, second thing, it will check the second feature. Let's say 300 is there. Okay, it will go to 300 and it will check whether it's a smooth and not smooth. Based on that, it will make the assumptions. So you can see we are trying to fit the classifier with the features and labels. Now we can, so everything is ready, training data is loaded. Based on that, now our prediction will start. So let's example, let's try to predict 310 and 1. So the output should be ideally, it's a 310 is very near to between 300 and 320, so it should give the output ideally as 1. 1 is nothing but my cricket ball. That's what, let's see what the output comes. Let me clean up here so that it will be easier for you to understand. Okay, so let us run our program. So let's see what will be the outcome. So you can see the prediction is 1, so that's what we were looking for if it is 310. Now let's do some tweaks. Let's say I am using 140 as a weight, and it is very smooth, I would say, because it's a tennis ball, so the output should be 0. Let's see whether it will be able to predict. So similarly, you can see the output has changed and the output is now 0. So it has made the predictions based on the training data. Similarly, I can give you one example that you can try it at your home. You can load all your images, whatever images you have, in a single folder of your family members, or let's say you have a rose flower. Just download all the rose flower images, maybe 100 or 150, 200 images, whatever is available on the internet. Create it in a folder, and then just try to pass on one flower. Give it a path, and it will try to make the predictions how much it is resembling with the rose flower, how much percentage it will give you in terms of percentage. If it is a rose flower, it will give you 90-95%. If you just try to give some cat or dog image instead of rose, it should give you a 0 or 5%, I would say, prediction. So just to let you know, everyone, before closing our call or before closing this presentation, lot of images has been, Google has already done a great job in this field. They have, you won't believe, they have loaded all the images over the internet as much as possible, classified them. It took them 2 complete weeks to load all those images, train them using the TensorFlow. That's why the model is readily available and you guys can have a look. So just search around, play it around. So believe me, Python is an easy language to learn and you will have a lot of fun. Thank you. Thanks for your patience for watching such a lengthy video, I would say. I hope you would have liked it. Thanks a lot. Take care. Bye. Namaste.